experience and expertise. And then in the next 3 slides, I will go a little bit deep into the building blocks of my skill set, what are the fundamentals I learned before I entered into the professional world, and some of the real world applications, just for you guys to understand like what are the real things which are happening outside academia, and how you can map them with your projects, and what are the key challenges which I faced over this period. And I will end with the last 3 slides on the key lessons which I learned and some of the future trends of data science and my advice to you all. So after this, there will be a time allocated for Q&A, so feel free to ask questions as much as you can. I would prefer to answer the questions at the end, but if you guys feel that there is any question, feel free to raise your hands. Cool. So this is about me. So I did my BTech in 2005 in computer science and engineering. It's been a long back, like almost in the industry for a couple of decades. So in my first decade, like almost like 10 years, I was in consulting. So I worked in companies like TCS, Cognizant, Capgemini, and Accenture in different types of roles. So I call myself as a BI engineer to start with. And then I was an associate manager in Accenture. After 2015, I developed a kind of a passion on data science. During those days, it used to be like called big data and analytics. So I used to search for universities where I can apply, because there are very limited universities offering courses like data science. So I applied to UConn School of Business. That was maybe one of the only school during those days offering data science. It's kind of a more hands-on course. So I applied to that, got into it, and then after a year, I graduated from there. And after that, from 16 to 2024, like this entire 8 years, I was working in different companies like Verizon, Google, and Amazon. So I was mostly in data science projects, in data science role. So here, like almost like 18 years of experience, working in different leading tech companies, having specialized skills developed over a period of time while working in real life projects. I started as I mentioned, I started as a BI engineer. So I developed a skill on BI, data analytics, machine learning, deep learning, and now I'm into generative AI. So here you go. So this is like the slide to showcase my curiosity, like how I developed my passion to enter into this field of data science. So I remember in 2013 or 14, during those days, I was working in Accenture, and we had a concept called Data Factory, where we used to get requests from the clients to deep dive into the data, try to gather data from different disparate sources, centralize the data, and try to build analytics on top of it. We got a request one day from my manager where he told that we need to deep dive further and apply some kind of analytics or sophisticated methods to go deep into understanding the behavior of the customers. So I raised my hand, and from that day onwards, I started a curiosity within myself, like, is it the data which is important or the underlying behavior which is more important? So that's why the draw came for me, is basically the question why, like why the data is basically following a certain trend. So that is during those days, uh, analytics was mostly, popular. So we used to apply a lot of analytics and statistical skills. But I was the first one who started applying k-means clustering. And k-means clustering nowadays, like everybody knows about k-means clustering, but during those days, it was called a more sophisticated method. So that was the aha movement when I tried to connect with the data, try to understand the data patterns, and more importantly, understand why the data is moving in a certain trends. So that basically drove me to move into this real world applications. And when I started understanding the meaning of the business impact, what are the drivers, right, which are moving the business metrics, then I started committing myself to this career. And at the end, when I saw that the analysis which I did was mostly actionable and helped to optimize the marketing strategy and helped to increase the sales and ROI, I started committing myself to this data science world, and then decided to apply for masters. This is a short sneak peek of my journey. In a high level, this is the expertise which I developed over a period of time. So in Verizon, I was mostly in the I was supporting the marketing strategy there. So my primary role was to enhance the e-commerce sales and customer experience. So one of the most important metric was increasing the channel mix. So it's like building propensity models to attract more customers and so that they can buy more products in the Verizon. I also try to understand how important it is to be more customer obsessed by going deep into the customer pain points and understanding their transcript applying NLP analytics. So after that, I started working in Google. So this is a little different experience altogether. It's mostly a statistics heavy role which I was in. And it's mostly about optimizing marketing strategies, budget allocation, and revenue modeling. So these are all different dimensions, but essentially it's applying statistical skills as well as building machine learning models to optimize ads performance, revenue prediction, as well as causal inference. For the last 3.5 years, I have been with Amazon, working as a data scientist, and my roles changed a bit because it's a long time I'm working here. But mostly, it's all about thinking long term and being customer obsessed and creating strategies in the fraud and abuse detection. So there are a couple of uh, projects, or maybe there are a couple of themes within fraud. One is like upstream fraud detection, where even before the customer is in the market, right, you understand how to assess the risk of the customers. And there is something called continuous risk detection model, which basically helps you to continuously assess the risk of the customers. It can be the risk in terms of financial uh, risk, or it can be different types of fraud and abuse. One of the example I can share with you guys is the ownership transfer abuse. So this is kind of an abuse which is very common in e-commerce platform, where you sell things in an e-commerce platform, and then suddenly you decide you stop selling things and you go to a third party and you sell your account, right? So your account still remains legit, but any bad actor can go and buy your account and start doing all sort of things, because the bad actor do not need to go through all the guardrails which Amazon or any other e-commerce platform has to register yourself for selling things. Any questions you guys have till now? Okay, so let me pause here and try to ask, like, how many of you guys are really interested to work in data science? Can you raise your hands? Cool. And how many of you are interested in the ML engineering side of it? Cool. So it's pretty much a good proportion. So just before moving to the other slide, so data science is a very, it's defined differently for different companies. So it's kind of a mixture of both experimentation as well as implementation, like the ML side of it. So I will cover a little bit more later. But let me go to the building blocks which I created. This is for my own, I created this for my own purpose, and then I started sharing with everyone, my friends and all. So if you see this thing, in today's world, it's pretty much we are suffering from information overload, right? We don't know, even while going into this field, we don't know which topic to choose from, which algorithm to work with, and which subject to pick, because data science is there are a lot of topics within data science. So what I'm recommending here is, if you are interested in learning data science, you can pick any book, you can go online, you can do all sorts of things. But if you are interested to go into the professional world, what are the core things? What are the non-negotiable skills which you should have before you decide to give an interview? So these are some of the core skills. Like, for example, the programming skills you must have is SQL and Python/R. It's not mandatory to know both Python and R. R is a little bit like more richer in the statistics side. But SQL and Python, these are two most popular, or nowadays it's basically a mandate to know SQL and Python. So that is one. The second part is machine learning and statistics. So in machine learning, again, there are a lot of topics within machine learning. I would recommend to like focus mostly on supervised learning and unsupervised learning. There are other variants to it, like semi-supervised and reinforcement learning. It's absolutely up to you. Like, if you are learning supervised learning, go a little bit deep into some of the algorithms. If you are learning unsupervised, go a little bit deep. These are two must-have skills for a data scientist. And for the statistical analysis, again, the descriptive analysis as well as the inferential analysis both play a crucial role, because I have seen in different interviews people asking very open-ended questions, which can be solved both using techniques which are in descriptive as well as inferential statistics. Having said that, the core skills are the one which you should have both the depth and the breadth. But when it goes to the outer layer, which is the common skills, it can be anything. Like, the common skills are basically like ML ops, right? Like, I have given a lot of interviews, but I haven't given a single one where you have to basically show a data visualization technique, or you have to show how to, it's basically the concept you should know. Like, for example, in ML ops, what are the tools, techniques, framework you have used to productionalize a model, build an end-to-end pipeline. You can acquire some of the concepts of cloud, like how the cloud help you to, deploy models. And even for the data visualization, you can learn some of the concepts and tools. And when you goes to the outer ring, which is basically the focus skill, these are the niche skill you must develop over of the period of time, either while working in the industry or at your free time. Like, for example, deep learning, NLP, graph neural nets, and generative AI. It's not mandatory to know everything, but I would recommend to have a deep breadth instead of depth of each one of it. Any questions? So once you have a core competency, right, in data science, you can start thinking about some of the real world projects which you can pick up and build your portfolio. So these are some of the list of things. This is, again, not comprehensive one, but some of the verticals which I found really interesting. But again, like in industry, you will not able to work on all of them, but maybe two or three of them. So, like, for example, finance, right? So finance is a big sector, and companies are investing a lot of money in detecting fraud and credit card risk management. So the impact is huge, right? You can boost the financial security as well as reduce the financial risk. In retail, you have, for example, in Amazon, we have a recommendation engine, but I'm not working on that. You have the customer segmentation, right? And you have all sorts of things which you can work on to strategize marketing as well as doing customer segmentation, which will, at the end, delight your customer and improve their experience. So in manufacturing, you have predictive maintenance and quality control. And I have seen companies having a lot of appetite spending money on this, especially Apple spend a lot of money to understand their manufacturing breakdowns, what are their product defects, and they do hire scientists working on this. And the impact, you can see that they have a lower maintenance cost, they can reduce the waste, and they can improve the efficiency. In terms of transportation, You see there are different facets to it. For example, Amazon spends a lot of money in terms of optimizing route, right? They are mainly focused on speed, like how fast they can deliver items to the customers. And we have a same day delivery today. And in Phoenix, I guess few days back, they started a drone service where they are delivering items within 1 or 2 hours across 50,000 products. So they spend a lot of money in terms of delighting customers for delivering things. So that is the North Star metrics for them. And if you see there, the impact is they're enhancing logistics, reducing fuel cost, as well as supporting sustainable transport. And the last but not the least is the healthcare. Healthcare has been also a pretty interesting uh, area to work on. So if you want to pick up any project in healthcare, you can go and find some open source, data and start working on it. It's mainly related to disease detection as well as treatment personalization. And definitely, it's basically at the bottom line, you are impacting the society in terms of enhancing the patient outcome as well as reducing healthcare cost. Again, this is not comprehensive, but these are some of the things you can think about and have a mental model on how you can map whatever things you have learned in academia and start implementing them. So it's been a while. I have been in the industry and like almost like a decade working in data science. It's very difficult for me to put everything in the slide, but one of the key things, sorry for the numbering, it got. So one of the key things which I found is important whether you will be successful in the industry or not is not whether you know the algorithm, not whether you know how to, experiment with data. Definitely you need to know, but one of the most thing is whether important thing is whether you are able to translate a business problem into science problem. So when I say translating a problem, it means that when you go to an industry, when you step into a professional world, right? The first thing happen is a business person who don't know anything about science will come to your desk and ask you whether this problem can be solved using data science or not. So at that time, you have to ask probing questions, you have to ask intelligent questions, you have to ask questions which can help you to translate these business problems into science problems. I have seen scientists like literally failing like in projects where they haven't even understand the problem and they started thinking about the solution. So understanding the problem, asking the right questions to the business is a key to be a successful scientist. Some of the examples which I can give is if somebody is like asking you to assess the risk of the sellers, right? You need to ask questions like who is the customer? What are the business metrics you are working with, right? And what are the success criterias, things like that. And once you know the problem, there can be opportunity to further decompose the problem into multiple problems. And there can be cases where you don't need ML solution for that. So I have seen in interviews people asking question about use cases which can be solved by product or engineering, and you don't have to have a machine learning model to solve it. Uh, the second point is data quality issue. So this is a very common issue, and I have faced in literally all the projects. So I have been like working in multiple projects. I started different data science teams, and I found that I'm working as a data quality controller rather than a data scientist. But it depends from organization to organization. If you have a DE or data engineer assigned in your team, it's work of the DE to make sure that they are bringing the consistent, complete, and clean data to you, because the data is super critical. Until unless you have a data, you will not able to build the model. Even if you build the model, it will be not robust and stable. So in that sense, data quality works is the key. And as a data scientist, you should have the responsibility to make sure that your data is as clean and as accurate as possible. Last, but the most important point is model deployment and maintenance. Super critical skill and knowledge to develop, and something which is like you develop over a period of time. It's not happen overnight. So and something maybe like interviewer love to ask this kind of questions, like you know how to solve a problem, but how do you know how to scale it? So there are a lot of different dimensions to it. I try to touch base some of them. For example, infrastructure and resource management. If you know cloud, that's great. But if you know how to use the different services, that is awesome. Because in cloud, you have different ways to auto scale your infrastructure. You have different ways to create endpoints. You have different ways to even move the data more efficiently and things like that. So it's super important in a high level, even if you are not going in an engineering role, how this infrastructure and resource work. Because when I started as a data scientist, I used to literally do coding in Jupyter Notebook, and then after my experimentation is over, I hand it over to an engineer. But now I have to keep the end-to-end pipeline running. So it's super critical to make sure that you understand the infrastructure. The second is model versioning and consistency. So this is something any MLOps tool can help you, but it's important to know how to understand the different versions of the model, why you are creating the different versions, and what are the methods you will choose to make sure that which version is running in production. Uh, Latency and performance optimization also plays a super critical role. So when you work in a real world example, right, you will never work in a single system. There will be multiple systems and multiple people or team will be owning those systems. So you need to be super cautious on the latency, because your latency is directly related to the customer SLA, as well as you need to be cautious on the optimization part of the models, like how you want to optimize it to make sure you are having the optimum latency. And there are different techniques. I mentioned a few, like quantization, pruning, and distillation. These are some of the terms related to LLMs and neural nets. You can even use advanced hardwares, but those are the advanced computes and the memory which is available. But um, understanding or knowing these techniques will definitely help you to optimize your pipeline. Even if it looks unimportant, but data security and privacy is like one of the key thing all the companies pay attention to. If you are working with red data, or if you are working with data which has like PIA data, you need to know how to encrypt them, or maybe if somebody is encrypting them, you need to know how to handle them. And these are super critical things in terms of maintaining the compliance. And last but not the least is the model drift and performance degradation. So this is also something very important. Like you build a model over a period of time, maybe a quarter or maybe a month, and then your model is started running and it becomes stale, and your model performance gets degraded over a period of time. So you need to know what are the techniques available in market today to monitor these kind of drips and monitor this kind of performance degradation. And what we basically do in Amazon is, in my team, we used to auto train this model. We used to auto trigger this model. So there are different ways to do it. It can be on demand. It can be triggered based on a specific event. But you need to at least know like how to keep your model robust and stable over a period of time. So here are some of the key lessons which I learned and wanted to share with you all. I'm pretty sure since you have already started working in science, you will understand more how important these are going forward. Like embrace curiosity. So this is the fuel, and this is the main driver. And it's not always important to be curious on the technique, but it's also important to be curious on the data, because data is coming from the real world, and you need to know how this data is coming from, right? So you can explore different types of data. There are a lot of open source sites are there where you can explore different types of data and algorithms, but mostly staying curious with the data is basically the key lesson which I learned to become a successful scientist. The second part is power of collaboration. So this is also super critical skill. The collaborative skill is super critical because uh, it's most of the time, 100% of the time, even if you are working in a individual contributor role, right? Even I'm working as an individual contributor, I need to collaborate with multiple teams, be it an engineer, be it an ML expert, be it like a business analyst, or maybe a product manager. I need to collaborate relentlessly because until unless I know the 360-degree view of the problem, it's very difficult for me to move. And these are interdependencies you need to manage. So developing a collaborative skill from the very beginning will definitely help you to be a successful professional. Coming to the communication, so again, the communication is super critical skill. I know people who worked in different types of technical, aspects of things, different cutting edge problems, but when it comes to making layman or a business stakeholder understand the insights, they definitely faltered. So developing a skill to not only learn and understand yourself, but also to make other people understand in a very lucid and easy way is a superpower, which I believe for any data scientist. The fourth lesson which I learned is learn from failures. I myself have applied more than 500 jobs before I got into Amazon. I have uh, I have been rejected more than 100 times, maybe, or maybe more than that. I haven't counted, but maybe at least 100 times before I got a job in Amazon. So don't get disappointed if you are, and again, like if you feel that you are disappointed, you didn't get a chance you have a dream company, right? You want to work with them, but you didn't get a chance. Don't worry, you can always get a second chance to work on. So what I would suggest is make sure you fail, but fail fast. And whenever you are failing, right, make sure you start learning what are the mistakes you are doing. So maybe in that case, like for example, if you're giving an interview, if you know that you answered the right thing, right, ask feedback. Try to ask feedback and see where you went wrong so that you can correct yourself. So failure is good, it's not bad. Most of the time, if you clear an interview in first attempt, then maybe there are a lot of things which you haven't learned. So it's good to fail, but it's also good to understand the mistakes. Stay adaptable. So super critical lesson. So I used to get fascinated with machine learning algorithms in early days. I used to go deep into them, and then over a period of time, I realized that the more deep I go, more I lose time to keep up to the speed. You see that how quickly in over a period of 10 years we move from ML to DL, and from DL to generative AI, and don't know where we are moving towards. Maybe like we are right now in Gen AI and AI agents. So try to learn as much as possible. It's absolutely fine to go over the breadth, not on the depth, because nobody can know everything. But at least try to learn like what are the new things which are coming up in the industry and where the industry is trending. Because most of the time, in my experience, I have seen that I got expertise on a specific niche skill, and then suddenly it got irrelevant. For example, when LSTM came, right, or GRU came, I started learning on it, but then again, the transformers like attention all unit came into the market, and everybody started using it. Cool. So some of the trends, future trends, which I think, in my personal opinion and whatever analysis I did, is important for those who are planning to work in the next decade. AI integration is a super critical thing which all the companies are working on. Even those verticals where AI has not been so popular, there also companies are investing heavily on AI. So integrating all their artificial intelligence, right, in data science methods and automation. This is the second point is automation. So this is again a super critical thing which is coming, or maybe companies have already started automating things using AI. One of the most important thing which is coming up, or maybe people have already started investing, is AI agents. So if you guys are interested in learning more on AI agents and things like that, these are the some of the things which are coming up. And and believe me, in companies will be spending a lot of money on automation. Again, when it comes to automation, people feel that my job is gone. Like if somebody is automating my job, like how will I get a job? So the thing is, there are certain kind of tasks which are super predictive and easy to automate, and there are some certain kind of tasks which are very difficult. So you want to be someone who can use these different tools and techniques to automate things, not someone who is doing some kind of job which can be easily automated. So being one step ahead in terms of understanding these different tools, as I mentioned, AI agents and different LLMs and things like that, will definitely help you to be aligned with the future. The couple of more things are real-time analytics. It has been there in the past, but focus are more on integrating AI in the real-time analytics and data democratization. So this is also something in terms of bringing data to everyone. And when I say data, nowadays the model is also getting democratized. For example, Hugging Face has so many models, right? Pre-trained models. So now speed matters a lot. Like if you want to do a POC, you can do in 2 days, right? You can easily pick up a model and start working on it. Cool. So before I end, I would like to give my own personal advice. This is nothing to do with any company or anything. Uh, the first thing is network relentlessly. This is super important. The reason is the more you engage with the science community in any capacity possible, like for example, attending conferences, uh, writing research papers, publishing papers, writing blogs, doing meetups, workshops, those, anything will help. It builds your network and also give you different perspectives. Leveraging social media, I think it's super critical in today's world. How you can leverage your social media in a right way. If you can build your brand in a right way, it can work wonders for you. You can follow different industry leaders. I intentionally did not put any name because I don't want to bias you all, but you can choose and like select anyone if you like, and then start understanding what they're trying to share in the social media. Finding a mentor. So again, like once you go out of college, there can be like finding a mentor can be difficult. There are, in companies we have, in especially for Amazon, there are mentorship programs where you can assign a mentor, or you can seek mentorship from senior professionals. But again, like finding a mentor definitely help, and use resources. So when it comes to using resources, the most important, as I mentioned, the most important challenge which I faced is information overload. And there is also a challenge called social entanglement. What it means is when you start going online, right, going any kind of course, like for example, Coursera, ADX, or any online platform, you fall in love with the platform and not with the course. So make sure you are not falling in love with the platform, you are falling in love with your topic. So that is most important. For example, books and blogs. So there are a lot of books and blogs. Don't fall in love with the author, fall in love with the topic which you are working on, and make sure you have a clear plan which topic you will cover and using which media. So the media is not important, the important is which topic you are working on. So I will end this presentation with the last line: the journey to be becoming a data scientist is a marathon and not a sprint. So if you think that if you become a scientist overnight, it's not possible. So you have to, it's a journey, you have to go through it, you have to understand, you have to make sure that you fail, but at the same time you learn from the failure and embrace the learning process, stay curious, and do not hesitate to reach out for help. Thank you. So feel free to ask any questions relevant to this session. Yeah, go ahead.
Branch of data science, so you think it would be a big entry level position?
So now the way the industry is currently moving, NLP will be the right, choice for the scientist. But again, it depends from there are people who are working in graph, there are people who are working in deep learning still now. So for example, in my project, I still have tree-based models when I'm doing some research on LLM as well. So traditional models will not go as soon as we think. They will still stay because there are some certain reasons for that. Uh, but again, like if you want to choose a niche skill, as I mentioned in my outer layer, right, a focus skill, NLP will be one of them. And you can start with maybe transformer, right? Understanding the architecture of transformer. Even understanding, even within the transformer architecture, you will find neural net, right? So understanding these kind of things will definitely help.
What would you say would be like the next era for Amazon after AI hype ends in this world?
What will be?
Like the next stage for Amazon after this AI hype ends?
Oh, that's a great question. Even I don't know. But to be honest, the way it's moving right now, I see the next 10 years. If you go back, neural net was discovered in 1940s, right? And then suddenly this kind of learning, doing back propagation started in 1960s. And then suddenly after 40 years, like in 2010 or something, like we started really using like neural net, right? So it took a lot of time. So I also feel that this is just a beginning. This AI is just a beginning. There are so many caveats into it. Still, we are not successful in. There are a lot of research products going on within Amazon where we are trying to leverage all these LLMs and see how we can use them. But still, we are not there yet. How to productionize these models, right? So I think it will take another 5 to 10 years to be in this space, in AI space, and try to understand which technique works well. So to answer your question, definitely AI will be the next big thing, at least for the next 10 years. Now, to move a little bit ahead, there are a lot of research going on in terms of understanding the human brain, in understanding how the human brain works. So there can be a lot of different new techniques coming up, but mostly it's aligned to AI.
What part of a data scientist job can sometimes feel tedious or challenging?
Oh, that's a great question. So bringing the data is one of the most tedious work for a scientist because most of the time, 80% of the time, scientists spend time in bringing the data, try to understand the data, and make sure it's ready for modeling. So we spend maybe 20 to 30% of time building the model and productionizing the model. Again, it depends upon what kind of role you are in. If you are in a ML engineering role, maybe you don't have to deal with data. But if you are a data scientist, then you have to take some responsibility of bringing the data. It's a tedious job. It's sometimes a boring job, but it is as it is, right? So even if you are working as an ML engineer, if you don't have data, you can't do anything, right? So bringing data, understanding the data, and like maybe going through, navigating through the caveats of the data is most cumbersome, I would say. Yeah.
So what is the difference between data scientist, machine learning engineer, and the data engineer? Which one is most related to?
Great question. So So in Amazon, we have within Amazon Science, we have, I can speak for Amazon because I'm working right now, but each company has a different title. So it's again a metadata. In Amazon, we have different streams. Like one is data scientist, another is applied scientist, another is econometrics, another is research scientist. So data scientist, the role is mostly experimenting with data and understanding the data, bringing the data and things like that. Even if you are not productionizing the models, it's not expected from you. It's basically building the model, doing the experimentation and handing over to the engineer to take care rest of the things. Now, in Amazon, things are a little different right now. Like, for example, for me, I'm working as an applied scientist, even though my title is data scientist. So in applied science, what happens, you not only need to define the problem, talking with the business, but also you need to bring the data. You can work with the data engineer, bring the data, build the model, as well as you are owning to productionize the model. So you are basically both a scientist, data scientist, plus a ML engineer. So that's why people get paid more in applied scientist compared to other roles. And at the same time, you have to be a research scientist. So applied scientist is a data scientist plus research scientist plus ML engineer, where you need to contribute, and it's within the guideline, like you have to contribute to the research community, and it can be in any capacity, like publishing papers in premier institutes, or maybe reviewing papers, and even within Amazon.
You just mentioned technology is evolving from the traditional machine learning to deep learning and to AI. So what I know is previously have the linear regression, random forest, like GBM, that's the traditional machine learning, and the after that embedding transformer and to the currently generative AI. So what's the impact? Just kind of the technology involving what's the kind of the impact of your current task. So for example, if you got a new project, you will start from use the traditional machine learning first, or then to the deep learning. And
yeah, that's a great point. So my domain is a little different. So I'm in fraud and abuse. We heavily suffer with data volume. So since the data volume is pretty less, we suffer with class imbalance a lot, and the data volume. So sometimes in some of the abuse, like as I mentioned, ownership transfer, right? Getting a proper data volume, having the proper statistical power is very difficult. So what we do, we start with simple, as you mentioned, right, tree-based models, which becomes very easy to implement. And we tried out deep learning frameworks. Sometimes it works, sometimes most of the times it suffers overfitting. So if your data is less, you can use deep learning to do data augmentation using autoencoders or other techniques. But mostly if you have a lot of data, it's like there are a lot of projects people are working with using deep learning framework. Coming to the LLM, or like generative AI, again, there are a lot of research going on. The proportion of models working in production is pretty less. So there are a lot of POCs and research going on, like whether we can use LLM as a classifier, right? Like traditional methods. So I even have some papers on that, where I found that in some cases, LLM can be used as a classifier and can outperform traditional models as well. But the challenge is how we will deploy the model, like how we will scale the model, and how we will make sure that LLM is also learning is a big challenge, because sometimes you want to follow the easy route, right? Like maybe you do zero shot prompting or few shot prompting without even like training that model, right? But most of the time in industry, those are some of the specialized use cases where you need to go with fine tuning the model. So those are some of the challenging things. We still don't have answer. It depends upon case to case. But coming back to your answer, definitely traditional models still helps, because these are easy to interpret, easy to deploy, and easy to productionize.
Freshman right now. Do you have any advice for internships in data science? I've worked on a couple of projects, but I don't know how to like expand my.
Yeah, you can reach out to me in LinkedIn, but the thing is, there are like time and again Amazon like they post these kind of opportunities. If it is there, you can browse through the career page and look at it. If there is any internship opportunity, you can apply to that, or you can reach out to me. I can refer you.
If you were starting out as a data scientist now, fresh out of college, what would you do differently? What skills would you focus on more for?
Yeah, as I mentioned to him as well, like NLP will be my super critical, super focused skill to work on. I think nobody will ask you to build a transformer from a scratch, to be honest. They will still value your coding skills, be it Python or SQL. So I would suggest to, if you are targeting a data as a data scientist, I would suggest you to solve easy to medium problems, data structure problems. But if you're targeting as a SD or a ML engineer or a maybe senior ML engineer, you have to work hard problems. But those are not like those problems will never come in your day-to-day life most of the time. But you have to do it that hard way because there are no other way to do it. That is the only way, because to be successful is a different thing altogether, and to crack an interview is completely different thing. You have to focus and give dedicated effort for that. So the only for the interview perspective, I would suggest at least solve a single problem a day, if possible. Like maybe time that out, like maybe use 20 minutes or to solve a single problem, and build that muscle so that over a period of time you can easily solve these kind of problems. Yeah.
Say like I have some proficiency in SQL and I want to focus on the data quality part. So what more like advanced I can do in that area to like.
So I have seen a lot of companies hiring data scientists with only SQL skill. Believe me, SQL is very tough. I'm telling you. The reason is it's not implementing the SQL, but understanding the syntax SQL, but understanding the problem which will be given to you in that specific time of, like, it will be timed, right? Like they will give you hardly 10 minutes or 15 minutes to understand the problem and then translate it into a SQL syntax. So it's again, if you know SQL very well, if you know how to translate those complex problems, business problems, into SQL, you are still valuable. But again, like I would suggest to know Python, because everywhere we are using Python. Until unless you know Python, you will not able to move the data to production. If you have interest in data quality, I would suggest you to go in the data engineering route rather than going into as a data scientist, because the way industry is moving right now, most of the data scientists will be an applied scientist going forward. So it's better to stick to data engineering role if you are mostly focused on data quality. Any other questions? Any challenges you guys are facing, or any confusion you guys are having in terms of understanding which one to work on and things like that?
For example, in platforms like Coursera, there are many courses by companies like ABM, Google, that they give you like, for example, a certificate for data engineering. They give you like a set of courses, like 12 or 13, in order to get the certificate, and it's like a small breadth of every skill. Would you recommend me to do something like that, or better to take a specific course for a specific skill, like SQL, NLP, and all that?
It depends what you want to do. Like again, there are two things. One, you are learning as from your interest, right? You are learning, you want to be a great professional over a period of time. And the second thing, those two are completely orthogonal. Like another thing is you want to crack an interview, right? So if you're planning to crack an interview, these certificates will not work. Even your resume will not work. Nobody will look into your resume. If you are coming from Harvard, you are not able to solve a problem, you will be rejected immediately. So you need to understand two things. Like if you are if you dedicate yourself to learn over a period of time, set aside a time where you only dedicate yourself to learn new things. You can use Coursera, you can acquire a lot of certificates, but I don't think it has any value in terms of industry. It's for your own learning.
These problems you're talking about, are you talking about like weak codes, or what specific problems? Where would I find, how I can?
So yeah, LeetCode is one of them. LeetCode, HackerRank. So when I say the problem, I mean both the technical aspect of it as well as the business aspect of it, because in science, what happens is in SD track, you will get a straightforward question from LeetCode or whatever it is, right? And there is no business element to it. But in science, what I've seen is there are companies who are not going to the data structure, but at least they are testing your data wrangling or data manipulation skills using pandas or NumPy or anything, right? But when they're testing your skills, they're not testing you whether you have memorized the syntax or not, but they are testing whether you understand the problem and what's your approach in solving that problem. So I can name a lot of companies where they look at your thinking process more, and they are open to use, like they allow you to use ChatGPT or whatever within the interview itself. The only thing is they are not looking whether you are memorizing the syntax. What they're looking is what is your approach, right? What is your skill? And again, like data science is it's a very multivariate skill, because if you go to Facebook, there are roles like product data analytics or data scientist, right? So if you apply for those kind of roles, you need to definitely have a business acumen and the product sense of how to even approach the problem. They're not maybe looking for Python skills, but maybe SQL skill will work there. But at least you need to have a product sense, like how to analyze a product, or how to analyze a feature, or even how to launch a feature. You need to understand, because you need to work very closely with the product managers or the product owners who will be giving or assigning you work. So again, it depends. But again, LeetCode, HackerRank, are some of the good resources where you can basically brush your skills on data structure.
All right, thank you.
What he asked and whatever you answered. When we talk about, as you answered, there are two sides, the technical side and a business, what you understand from the problem. We can go for the technical side to read code, HackerRank and everything, right? But when we talk about from a business perspective, or how well we understand the problem, are projects the only way, or are there any other resource or any other methods to improvise or to?
Again, this is it depends upon which company you are working on. That's why I said that when I went through that real world examples, right? You need to develop an interest on these business problems, which is super critical, because now I know you know everything about technical things, right? Like you can write algorithms, you can apply models even better than who is there in the professional world, right? But what you lack right now is the business knowledge, because you haven't worked in the industry, right? So you need to develop that interest, that muscle power, and it develops over a period of time, right? To understand the business, like why they're so much interested in applying science projects, right? What is the problem? Why is the problem even exist today? So to understand this kind of things, you have to follow, you can follow blogs, you can go through the specific company site to understand what are they are working on, what are the projects they worked on, what kind of business problems they are solving. Even if you look at their sites or blogs, like even in Amazon, right? If you go through AWS blog or any blog, you will see that the solution will start with some kind of a problem. And if you can map that business problem to that solution, then it will be super easy for you to crack any interview, because the interview will never start with dead end question, like what is technically solving a question. It will start with a problem. So understanding a problem is super critical, and understanding a business problem is more critical, because You can understand the technical problem. The only thing is you need to map that business problem to a technical problem. And there is no easy way to do it. I understand. Like I also face the same issue. It's never easy. Nobody can teach you how to do it. It's yourself. You have to take the initiative to transfer it. In YouTube or even in other online sites, there are a lot of good sites. Even in Medium, I have seen people posting their experience, interview experience, where all the questions are there, mostly the business questions which relates to their business, like different companies business problems. If you go through it, you will see that how they're thinking about the problem and how they are converting those problems into technical problems. And again, these are mostly open-ended questions. So there will be questions which can have multiple answers. So the interviewer wanted to see like how you are approaching those problems, what is whether your thought process is correct. Not only you are thinking about the right technique to solve the problem, but how you are thinking about scaling that problem, how you are thinking about sustaining that problem, or how even thinking about the sub problems which might be hidden within that original problem. So there is no straightforward way to answer this. You have to learn on your own and understand the business.
Data science and machine learning job, they require at least 1 to 3 years of experience or either a PhD degree. So how come a newly grad student apply for that job?
Yeah. So these job descriptions are pretty, it's pretty nebulous. It's very tricky. So when they are looking for 1 to 3 years, that means they are not looking for a experienced candidate. They are looking for a freshers. So if you have 1 to 3 years of experience, that good. If you don't have, then you can always show your projects which you have worked in the industry. And this is again a tricky thing. When I also started my career, it becomes a challenge because there are so many experienced people out there. Why they will hire you? Believe me, there are a lot of requirements for entry-level jobs as well, because it depends like what kind of role you are applying and what kind of what level you are applying in a company. So never get disheartened with those job descriptions. Directly get connected with the recruiter and try to understand whether you are eligible or not. I'm pretty sure that those are simply noise. Any other questions? Cool. So I will then end this session. So feel free to connect me over LinkedIn. I'm easily reachable, and let me know if I can be of any help of you guys. Thank you.